Thanks very much for inviting me for this session. A lot of people may wonder okay, why I've chosen this subject of data analysis, powering, and that too, I'm trying to link it with the net zero goals. See, net zero has today become a buzzword. Wherever we go, everybody wants to say, I wish to be or aspire to be going for a net zero, or I am in the process. So to look at it, this is a very cliche, which I got it, that data everybody knows, but that's a new oil. But analytics actually is a combustion engine. So in a very short while, we'll dwell upon it. I've got some case studies at the same time to set the context. Data, it plays a very significant role in accelerating the journey to net zero. It's a way, it's a pathway. It brings in a lot of visibility in creating baseline, identifying emission hotspots, etc. As we go ahead, we'll look at it. Now, just to set the context, before we do a deep dive into this energy analytics aspects, maybe you may have had a look at this. Energy is one very important element, dimension in the whole value chain of the resources which we have on this planet. So today you have on the left-hand side only one planet, but the way we are consuming our resources on the right-hand side as you move, we are overdrawing what we can generate. So this is where the dotted line shows that from 1970, if you map it, today we are exhausting our resources by around July. That's what it is. Now, in our corporate parlance, we say, okay, if the plan A fails, then where is the plan B? So in this case, please understand there is no planet B and there is no plan B also. We can't walk off from the planet. Okay. So the whole context over here is that energy analysis and energy is one of the very, very important dimension in the entire value chain. Now, the simplistic thing, many times people forget, people want gung-ho about solar and so many things. So clean. So first be lean, then be green. So the whole thing is, you look at your loads, that's we'll see how analytics is going to facilitate the entire process. Then whatever the loads are there, you can't bring it down to virtually zero. Well, everybody will agree with me. Then you make it very efficiently, and then you proceed for a clean energy or a green energy. Now, why I've chosen again the industry, because industry, if you look at it, it consumes a very lion's share in the whole pecking order. In all the buildings are there, infrastructure is there, in the entire built space footprint, if you look at it, in operation. So there are three distinct very elements, if you look at it. The entire process systems begins with the design, conceptual design, we call it. Okay. Be it an industrial process, be it a building process, be it air conditioning, be it a pumping system. So design plays a very important role. Second thing, technology. Technology has been leapfrogging. It has been evolving. There are a lot of technological interventions which are at our disposal. So we can look at it favorably. But the most neglected part, I'm very sorry. I mean, with all due respect to all the professionals which I have worked, this is the most the lesser due it is given, no weightage, nothing. Operational performance, people have taken it for granted. Like they say, I got the best of the chillers, I got best of the pumps, I got best of the solar systems. But many times when we go and question that, okay, have you ever evaluated what is the efficiency after even 6 months? Leave aside 6 years, that's a too long a time. People say we do not have any understanding. And once again, with all due respect, when we also give some recommendation, people will say, okay, we will see. Let's continue with our process. So it's a very lackadaisical approach which we have seen in the industry. Now, this is one slide where I want to bring out a lot of things. Today, the entire trust is on manpower reduction. Okay. So ultimately, when you reduce it, you have to have some sort of a intelligence, be it artificial intelligence, you call it as IoT, IT 4.0. There are a lot of acronyms which is coming. Ultimately, it's your asset. See, we buy a compressor, we buy a AC. It costs lakhs of rupees. When you're setting up a brand new greenfield project, a new factory, which I have been working, giving them some advisory in Godrej, outside Godrej, I'm sure everybody will agree it is costing crores of rupees. And when we talk about this asset optimization by building in data intelligence, which is hardly 2%, 3% of the cost, people will say, no, I want to cut the cost. I don't know cutting the cost at what cost. That's my whole funda. So ultimately, your maintenance, inventory management, then once you have an operation in place, there are a lot of challenges with the downtime. Today, people cannot afford to have a dive, be it a data center, be it an industrial process. I don't want to get into a deep dive on that. Operational efficiency improvement, that's something which we'll be dwelling upon in detail. And ultimately, all this gamut put together is ultimately culminate into your asset life good management, optimizing it. Okay. Now, today also, once again, I don't know if people are from purchase or a HR background, people talk about L1. So what I'm trying to say over here is, people, there is nothing on the radar of the procurement team or not as something as a life cycle cost, because people again give more weightage to the capital cost. It is very evident from here. It's no brainer that what is more of significance, okay, and where you have to play yourself. How do you position yourself? Okay. So this is one thing which I'm trying to reiterate. It's nothing. I'm not saying it's something rocket science. People are not aware of it. So the whole approach, if you look at it, it's a very systemic approach. Now, this is where we are getting into a detailing. So many times, be it a building, be it a data center, or be it in a factory, today also, when I asked, say at least roughly 60% of the time, do you have any understanding what are your process load, where is your end use energy happening? People will say we only have one reading, that is invoice we are getting from our discom, be it Tata, Adani, be it MSCDCL, be it anywhere from Karnataka, XYZ. Okay, so this is where the first circle, if you see, that you have most probably, that is at a macro level, people have some sort of an understanding, which is very inefficient. It is very deficient, if you want to say. Then comes the central level, that you have got a lot of utilities in any factory. If you look at it, any scale, be it engineering industry, with cement, it will vary. So you have got a central utility level. This also is quite significant. And ultimately, it is at a micro level, one has to understand that where is my energy spent. So very shortly, we will see, if you look at it, a typical, I'm taking about an engineering industry. It may vary from industry to industry. If you go to chlor-alkali, if you go to cement, if you go to steel, 50% or 40% is their energy cost of your total cost. Here in engineering industry, maybe it's 4-5%. It's like that. But you get the total energy part breakup. Manufacturing takes the lion's share, again in the pecking order. Then you see the air conditioning, air compressor, pumps, because pumps finds a very large scale deployment in the process industry, etc. Then definitely there are utilities, hot water generator and whatnot and all that thing. And ultimately lighting. Now today, people are, a lot of things are gung-ho about lighting. So it may go a little bit 5%, but I'm just estimated, put it at around, pegged it around 5%. Now, for data analytics, this is like a overview. So how is the system architecture happening? And as I told you, one is the design, second is the technology. So in last decade, we have seen a paradigm shift in the technological innovation. So totally now these things are happening wireless. Earlier, when I started my career, everything was wire. Today it's not. If it is not wireless, it is useless. We would say that. So right from the supply end to the distribution end to the process in between, then the cloud has come into the picture. It's a web-based system from anywhere sitting down. And in fact, we had a very good experience when this lockdown had happened. A lot of our team were at home, and we could sit down and monitor on a pan-India basis, a lot of locations, and tell, hey, look, just now is a lockdown. This is a Saturday, this is a Sunday. Why two pumps are running? Why the air conditioner has been left on? So on and so on. It was like a CCTV camera, in short, on a very common parlance, I would put it that way. So this is an overview of a system architecture. Now, to start with, as I told you, you had seen three concentric circles. So one of the example and a case study of that at a macro level is a very detailed understanding and a dissection of the analytics of the bill. So if you look at it, now most of the people have got this time of the day, metering system, okay, and rates are different. So I've just to show you that at different time of the day, different tariffs are there. There are some concessions, there are some additional, okay, tariffs, which you see on the red, that is on the additional side, 1 rupee 10 paisa, 0.8 paisa. So it is very prudent for a facility people to understand and see how can we manage by shifting the loads, whatever is technically and practically possible. See, many a times, it's no brainer. People will say, okay, in third shift, I'm getting a benefit of around 1 rupee 50 paisa. Why can't I take 60% of my production output in third shift? But there are a lot of process issues, there are a lot of operational issues, safety issues, etc. So we are not getting into those aspects. But there definitely exists a very good potential. One has to look at it, and people will benefit. The second part, if you look at it, is this energy spent over a period of time in shift and on holidays. So there is something called as a fixed load, and there is something called as a variable load. So people put variable load under the carpet and say, oh, no, 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 everything is so hunky-dory. Everybody is okay, okay. It's not like that. So if you look at it, the blue bar is the base reference. We have taken 100% on all the shifts. Then Sunday is a orange one, and a paid holiday where very hardly. So we were shocked and surprised that or even on a Sunday in a third shift, it is as high as 55% of the daytime, or if you look at it, of the first shift also. So this is something, an eye opener, that what is happening on a Saturday night, on a Sunday night. Night shifts are there. They are supposed to be virtually zero. Okay, some operational staff. So this is something coming as a fixed load, which is hitting the energy aspects very, very badly. So data management till today also, many times when you walk over, people will have meters. I'm not getting into selection of meters. People will say, "Nee, wo kharcha hai." Many people are asking me, by putting the meters, how much amount of money I will save. The next question I ask them, that if you are going to buy a car, and if you tell the car manufacturer, please remove the dashboard, how much reduction in your capital cost of your car will come down just by not giving me the dashboard. So the metering and this energy data analytics entire gamut is nothing but adding a dashboard to your car. Okay. So this is something, I don't know how people are linking up saving to the putting the meters. Second thing is, people are gung ho just blindly putting the meters. There is one organization I'm working in. They are saying, okay, I'm so happy, I'm having 23 meters. I said, then afterward, that what? He said, no, that's it. We'll be taking a reading. I said, you'll be taking a reading jolly well, putting it in Excel and put it in a drawer and then file it and forget it. So that's not the essence. The whole thing, the conventional aspect of manual data has to go. That thought process has to change. So the essence is really online. That is where we'll be showing you 3 case studies over here. The first case studies, okay, everybody is so happy by putting a solar. People will say, I put solar of 4 megawatt, 2 megawatt, 1 megawatt. But people are unhappy when I ask the next question. Are you monitoring that whatever is your design performance, of course, with due respect, your iteration, year over year, whatever happening, is it matching with your actual performance? So this is one small case study. It was a brand new plant, and we were mapping it. If you see on the right-hand side, our solar was contributing nearly 18-20%, and it was good. All of a sudden, we saw in September, October, it came down to 11%. And that is the time. See, the whole beauty of this data analytics, we don't have to go to site. Okay. And believe me, that was a COVID time. Nobody was allowed and all that thing. Sitting down at home, sitting down at any place in the world, we could see where was the issue and where was the challenge. And that is how. So this is something. So first of all, this is macro management. If you would have not had this sort of a format, you would have not come to know. But don't worry, I'm not saying, just for your understanding, I'm trying to bring. We were not waiting that for 3 months we wasted the energy. You may wonder that I'm showing you this way. No. So if you look at it, the first part is the cleaning aspect. Now there are a lot of auto cleaning systems have come in place. Like, people say bucket bath saves water, sprinkler bath in really wastes water. But here it is a sprinkler which saves the water. By putting a bucket water wash, we actually use waste the water. The actual issue was with the inverter. See, I'm mapping and showing you time of the day, how the sun path is impacting the solar generation. So if you see, the light blue is where the generation happening. On the extreme right at 9:30, there is zero generation. Even at 1 o'clock, it is generation is zero. And even at 5 o'clock, the generation is zero. That means it is very evident there is something technically called, we call it as a strings. So there was a string of certain solar panels which was attached to the inverter, and there was a fault in that. So had we not got the information about, and that daily monitoring is coming, just because presentation I'm not showing you, immediately we logged on to it. Then we had to send it for repair. It was under the warranty. Thank God. Had we not discovered this, had we happened after 1 year, we would have burned a hole in our pocket by repairing the inverter, etc., on at our cost. So this is one case study which on the solar part, which everybody is familiar. The second big ticket item is a compressed air management. And compressor is used anywhere and everywhere in the industry. If you look at it, even if you go in a gala, I'm working with a lot of MSMEs. So you will see a small compressors also working. The compressed air is the most inefficient form of air or energy which you say. That 7 units of electrical energy gives you 1 unit of compressed air. Now here also, when we ask somebody that, have you seen what, can you tell me how your compressor? They say, yes, yes, yes. I have got a 500 CFM machine. I'm just giving you a round figure, 75 kilowatt of motor, and an i3 motor, VFD, blah, blah, blah. Okay. Now, there is something called as a SF. SF stands for service factor 1.15. So when I went into a little bit of a deep dive, and facility people, can you share me with your technical details? So I said, see, boss, your design criteria when you are evaluating your specific energy consumption, you are saying it is 0.14. Actually, it is not 0.14. The manufacturer has very clearly stated that a motor is designed to take 7.5 or 75 multiplied by 1.5, that is 86.25. So ultimately it is 0.16 kW per CFM. That's the design. So a lot of people are under a lot of understanding. I do a little bit of a evaluation also for some organization. Then they present this picture. So this is again a design aspect. When you act, this is really 14% increase if you look at it, the design itself. So when you are shortlisting and selecting compressor pumps, and believe me, the codal life means the life of all these equipments, around 14 years. No management is going to buy a new compressor or a new pump. Even 10 years, of course, today technology is coming up, and I've been seeing a lot of old compressors. That time, even I was not even there. So things, and they are not even monitoring. People put not even energy meter, no airflow meter. So they don't have any understanding of the SEC, which I'll be sharing with you shortly. Now, this is one major challenge I'm showing you in the industry, where the compressor, there are two parts, supply side and the demand side. And this is the demand end, where your production always goes on varying, the requirements are varying, and you see a fluctuation of the air, and that is a perennial problem. So to overcome, what people do, they overpressure, set more pressure to overcome this, and then they supply the air. So this is how you see. This is a conventional one. You put more pressure, and then you see that there is no pressure drop in the plant. Well, no, there is a solution to that. And see, this is what happens. This is again the data which we are getting from data analytics. Okay, we don't have to run around, we don't have to go over there. So here, because the setting was not proper, you see there are 3 compressors in operation, wastage of energy, load and unload, load and unload. You see that graph going up and down. So C1, C2, and C3, 3 machines are operating. One is consistently operating because of the VFD, etc. Then by doing a proper setting, and putting an intervention, this is a technological intervention. We call it as an intelligent flow controller device. Okay. You get a constant pressure. You are assured of the constant pressure. With that, we can switch off one compressor. Only 2 compressors are working. One will be modulating. One at the base load, one will be to do the peaking load. As per the demand, it will vary. So all those variation which you were seeing, that red graph earlier, and here you can see the analytics, everything, how many hours it is operating, how many hours are off. So these are the dashboards, widgets, whatever the terminology you may call it. But people don't have time to look at all these things. This is just a case study. When you have to look at it, when you look at the anomaly. So on a daily basis, we monitor what is the normal meter cube, that is the output, what is the input, kWh. So you have a SEC, and this is where you see, purposely I'm showing you, there are 3 compressor houses. At some of the compressor houses, the efficiency is very, very bad. So everything is not good. See, we have to understand there are certain challenges, and bad means it's not something, everything is due to operation. There are certain technology issues, there are certain operational issues, there are a lot of issues. But ultimately, you have to face the facts. So once you see that deterioration happening, then you go back and you see what is happening, why it is happening, where it is happening. So this is something of greater essence that on a daily basis, just because it is presentation, I cannot show you all the small nitty-gritties and the nuances in which you get into it, but I'm showing you at a macro level, on a monthly level. So if you see the compressor house number 2 is the best, higher the ratio for one unit, I'm getting the best output. This is what. Even again going to the dashboard, the dotted line says this is a baseline. As I told you, this data analysis, it gives you the visibility of the baseline, emissions, identify the hotspots. So this is where actually what I was meaning, that you have a baseline. There is one compressor which is operating at 9.9. The other compressor is operating at 6.5, 5.5. Not only this monitoring, this also strengthens and confirms going to the management and saying, look, we want a budget. So buy a new compressor which is going to cost me 25 lakhs. The savings will be this XYZ, and the payback will be well within 2 years. And it's not ad hoc. It's not one of the time. I'm showing you 10th of August, 11th of August, 12th of August. You today also, if you want to see in September, October, any time of the day, any year of the day, any date, you can fall back and get this information. That's the beauty. That's the thing of the data analytics. That's the power. Now, the last case study before coming to an end, this is the second, this is the third case study. This is the HVAC again. So air conditioning, be it a data center, be it a building, wherever you go, air conditioning is there. Okay. So again, this is one thing which we mapped it. See, understand, on the top graph, first concentrate over there. We are mapping the total air conditioning load. Okay. And January to January, you have taken purposely. One year January and another year January. Okay. For a apple to apple comparison. The blue graph on the top, which you see, is the chillers, which is consuming most of the time major energy contribution. And we focus on chiller. But chiller is also the loading, unloading, the operations, the efficiency functioning is dependent on your condenser water pump, your cooling tower, and your chill water pump, because nowadays everything is installed with VFD. Again, that is the one thing that everybody thinks that by putting up VFD, it is a panacea, like taking a pill for all the illness. Lakho dukho ki ek hi ilaj. We call it in Hindi, something like that. So putting VFD does not absolve anybody for energy efficiency, and it's not something a sure thing. So this is where we are mapped. Now, very slowly, I'll explain to you what is it like. So if you see on the January front, the total consumption was 30,000 units, of which the contribution from the chiller was 14,400. If you see, my pump contribution was 3,700, 3,200. Now, the next January, if you see, marginally my overall consumption has come down from 30, it has come down to 29. You can say it has remained same, but very surprisingly, my chiller consumption has gone up. So in spite my chiller consumption going up, my overall consumption, I have been able to balance it. Now, why? What is the reason? This is because of the pump, which people take it for granted. In fact, the pump consumption, okay, many times it is coming to nearly 20-30%. We have done a detailed analysis. It depends. You've got a primary fixed and a variable secondary system. People have got a primary variable system. There are a lot of systems out there. I'm not getting into the nuances of the technologies over here. But the whole, the matter over here, the proof in the pudding, actually, if you want to see is this. That pump plays a very important role. The second analytics here, the beauty over here is, come month of April and May, definitely there is a summer coming in, and you see the ulta bell curve, okay, inverted bell curve. So that is there. So from 30,000, the overall increment has come to 46,000. From the chiller, it has gone from 14,000, it has gone to 24,000. Fine, acceptable, because that is there. But now look at this. Now the pump consumption, it has gone up to 4,800, and that is 4,400. Obviously, the pumps have also increased. But lo and behold, come the month of June, in fact, my total consumption has gone up from 46 to 50. In fact, my chiller consumption has gone up from 24 to 30, because June in Bombay, it does not rain. It's not, and even if it rains, wet bulb temperatures and all that thing, the technical aspect, it's not a winter. It's not like Delhi, that when your temperatures are really down, you see a significant drop in your temperatures and your power consumption. But at the same time, please look at and correlate my pump consumption. So for the 50,000 and 30,000 respectively, chiller consumption 30,000, I'm spending 3,800, and here I'm spending 2,900. So why did I spend same amount in the January? If you see, there is no much difference. If you see the January pump consumption for a 14,000 chiller consumption is too high. If you look at it, it's too high. So this type of analysis, this type of historical data, this type of a trend, when you sit and analysis, the whole summarization, what I'm trying to say, again, by putting IoT, by putting a data analytics, energy management system, if the human intelligence does not sit behind and does this analysis, then everything is nothing but the academic exercise and a lip service. Now we will get into the detail why this has happened. Again, if you see, this is where I'm showing you monthly. On the 1st of January, for the chiller consumption of 500 units, look, and my chill water pump is 127, 115. But if you look at the trend overall over the month, if you look at it on 6th of June, or even on the 7th, 8th of June, maximum, it is around 800 units. For that time, the chill water consumption was only 85 units per day and 81 units per day respectively. So that means definitely on 1st of June, something has gone wrong. Now, again, the whole idea of sharing with you this, that this monitoring has to be done on a daily basis. It hardly takes 10 minutes. You have to look at it. You have to refine your baseline and say that for this much amount of chiller consumption, 800, my water pump consumption should be plus minus 10%, whatever it is, 85 and 81. Now, this has come to 127. Now, why? What has gone wrong? So this is where, again, your analytics comes into picture. This is the screenshot which I'm showing you. This is your chiller consumption. This is your chill water consumption. On the right-hand side, you see that 127 and 151 for your understanding. Now, when we get into an enlarging, somebody has started two chill water pumps, and that is why your it must have, the VFB must have been bypassed, and that is why you see there is an increase. You can see that jump. Okay, now when did it happen? That also you can see at 7 o'clock. So immediately you can call your facility people, the group all of people, the frontline people, and tell them, look, did something happen? So then what happens? There are two aspects. People will feel, yeah, somebody is watching. Had this not been there, this would have went on till next 15 days, 20 days. Nobody, see, everybody doesn't take around everybody. Everything is not so perfect in the industry. Let me tell you. Okay, I'm sharing, I'm being a very open. Uh, but you have to understand there are some. So this tells you where exactly at what time, and after doing that correction, you see that drop happening again to 3.4, 3.7. Again, on the 2nd of January, you see that again, Ulta U curve. You see that whole thing, condenser water pump, it has gone up to 14 and 13 because 2 pumps were started or 3 pumps were started where it was not required. VFD was bypassed, and it must have happened in the night time. If you see the time is at 4 o'clock in the night, it is third shift. So there was a complaint. Okay, the chiller was not working. It was for a process. That fellow could not understand. It was PLC. Everything was there. Everything was bypassed. He put all the 3 pumps on, saying that, okay, there should not be complaint. See, this is the industry. This is how it happens. There is a disconnect between the energy efficiency team and the operation team, with all due respect. But we have to work together and we have to see. We have to facilitate. It's not then putting them on the other side of the fence. Okay, so you have to understand that technical difficulties also. So here, if you look at it again on the 28th of January, again, you see everything is a streamline. So this is how you have to really monitor. Second thing is the specific energy consumption, which we talked about compressor. There is a specific energy consumption also correlated to the air conditioning system also, if you look at it. So once, if you see, purposely I'm showing you, again, the technology says that my energy consumption should be 0.53, we are getting 0.5. Some days we are getting 12, some days we are getting 2.4. Here, what again I want to bring out over here is that time and again, we have to be very, very vigilant on all our sensing devices, field sensing devices, right from calibration of energy meters, flow meters, airflow meters, BTU meters, the temperature sensors. Even if you see the BTU meters has got certain sensors. if the sensors itself develop a challenge, this is what has happened in our case. So you will get a totally off reading. And then you'll be surprised, okay, 0.153, how can 12 is something which is very like not acceptable figure or very weird figure, technically not possible. It is not technically possible. So then immediately once you investigate and then you see, after you do your correction, even positioning of the sensors, please be careful. Positioning of the airflow meters, energy meter, even if you put upside down, it will work. But airflow meters, it has to have some distance before and after as per the diameter. Your sensing in the BTU meter, etc., etc. A lot of things are there. So these are the things which play a very, very, very important role in the entire gamut of our energy data analysis. So we have covered this three aspects about it. So, okay, for a short time, we did immediate correction. If you go back and I'll show you this figure. Had this not correction been done, then whole of January, we would have continued at the rate of 127 units per day for the chill water pump and 151 against whatever you see the average, it is coming from 85, 100, 90. Okay, if you can take it out average and you can define a baseline also. And on the right hand side also, we have devised the format that it is constituting. Chill water pump is around 11% and condenser water pump is around 13%. So both put together, I told you, it's as high as around 20-25% is there. Now the whole again challenge is data analytics. Any agency, all are good. You can hire or you can. The whole success lies in application engineering. Now, what is application engineering? These formats which I'm showing you, right from our solar, then for our air compressors, for our air conditioning, the engineering team for that particular unit, manufacturing unit, has to sit with the people who are doing the IoT based integration and guide them and develop these customized reports. Otherwise, the application people, those who are doing over there, they are very good. They have got the domain knowledge, expertise in the software, etc. But they will not understand your requirement. I'm not able to tell you. I'm just now working on an advisory to one unit. Believe me, for 1 month, every week we are having two round of meetings, and firming up this type of reports, formats, and dashboard the way we want. Because you don't have to blame them. They are good. They have got their domain expertise. But how we want the report, and this report, we had to tell them that every day at 8 o'clock in the morning, it has to come automatically in the email to the respective people whom the email IDs which we'll be sharing. So right from the vice president to, if you want to put it to the chairman, you want to put it to the managing director, you want to put it to the GM, a manufacturing head. So different report can be configured, because that person will not be able, would not like to get into all these nitty gritties. They would like to have a cockpit view. Cockpit view, we call it as a bird's eye view. So that immediately they say something is wrong in the process and all that thing, alerts, etc. So these things are really, really very, very important. Okay. So as you can see, you can figure out where the things are going horry. So we have just estimated how much amount of savings and what is the carbon. So ultimately, the potential areas where one can look at it, please monitor the chiller efficiency. The BTU meter will be hardly costing you 2 lakh, 3 lakh. Okay. Even if you have to retrofit, please, I would strongly recommend the people to do it, because if you look at the chiller cost, the entire is hardly anything. VFD operations, as I said, putting VFD does not absolve everybody and anybody for energy efficiencies. Monitor how we are operating. Even chill water reset, as the temperature goes down, okay, the set point also has to reset, because once we put it, nobody resets it. So this is again a very good area where one can be look at it, and timed operations, etc. Cut in, cut out, etc. has to be there. So now coming to the end of the presentation, there are certain challenges, okay, and the challenges will be there. They are all manageable. There are a lot of mitigation strategies which are in place. So when somebody is engaging with the energy management system agency, okay, the first thing has to be a clarity of the scope of work, that what is required, On that, the entire financials, costing, mandates, both sides. I would be a devil's advocate. I would like to take the side of the energy management system people also, because many times they also shortchanged. Okay, they have said, oh, because they are also putting mandates. So you have to be very clear. And organization's team has to be there. Allied teams. I'm saying allied means people may be there from production. Production guys should not come and say, no, I wanted the reported this way. For changing every report, there is a time, and then there's a cost. So you can negotiate and say, okay, 10 reports will be free of cost, or it will be built it in your cost, not free of cost, will be built it. All meters should have RS4. People buy, shortcuts, and they said, I got a 1,000 rupees meter. Then they say, oh, I cannot now integrate. Okay, so then connectivity. Then people will say, I got 4 to 20 milliamps. I'll put a converter. See, all this thing doesn't work. Then there are a lot of issues with the converter, data loss, etc. Data adequacy is another very important part. So meters, register details that fellow should be able to share, because ultimately the energy management system will be able to only link once you share the register detail that you want voltage, current, kilowatt, kWh, airflow meters, etc., pressure, everything. So there is something technically we call it as a register. If they are not willing to share, then there is an issue. You cannot do it. Even the protocols, you have to be very clear. It is supporting BACnet, it is supporting Modbus, LawnWorks. There are different protocols with different OEMs, service providers, etc. That you'll have to also be very clear on that. Otherwise, there are certain interface, we'll have to buy, and for which there'll be a cost, and managing those interface also, there will be a cost. Good amount of network strength is important, because now today everything is on the cloud. It works on the SIM. So that is one thing also. Otherwise, there will be a data loss. That will be totally a data loss. And once you have the system in place, it is worthwhile doing a exercise once in 6 months to validate that whatever the data you have on the meter, the same thing is getting reflected on your screen. Or is there some sort of a issue, or many times there are some calibration issue, etc. is there. So both ways, both put together, data adequacy, that is very important. SLD is very important. Unfortunately, I'm very sad. Many times I ask the people, 5-year-old commission factory industry, he said, no, the SLD is not as is where is. It is the old design type SLD. Lot of things have undergone change. But if it has undergone change, it is for you also to update the SLD. It is in your interest, in fact. So that is something. And all your meter settings, many times you see the meter setting CT ratio is 100, whereas actual CT is only 400. So you'll have a totally wrong reading coming on your meter, etc. So these are some of the challenges which one has to look at it. Report, I just gave you a very in-depth understanding and example. Same thing with dashboard, widgets, and all that thing. So ultimately, coming to an end. So the entire thing is that good amount of engagement, technical engagement, managerial engagement is required to make this a grand success. And please understand, 3 P's. One is people, another is patience, and third is perseverance. You must have thought 3 P's mean that planet profit. I'm not talking about that. So ultimately, you are playing with the people. So you have to motivate them. You have to make them understand what is the benefit. People will say, oh, net zero hote rahega, mere ko kya karne ka hai? What is my role? So understand the importance of their role. So people has to be really motivated. They have to be really engaged, That is one thing. Patience. It takes a lot of time. Believe me, this will take nearly 6 months to streamline your system, and ultimately you have to manage. And then you'll have to pursue. So perseverance. So these are 3 very important parts. So data analytics is like a lever, I told you. Okay. It's a significant lever in your journey of accelerating your net zero. So I just thought of it, very apt, that you give me a long lever enough and a fulcrum, we can move the world. So you can do anything once you have the proper data and you have the data analytics in place. Today, we are suffering from data obesity. People have data, but analytics is totally minus. Thank you very much. Any questions? I'll be glad to
have. Thank you, Mr. Rumi Engineer. And it was a wonderful presentation and very insightful. First, I would like to ask one question. before we open it for others.
Sure.
So right now in industries, there are many points where we need to monitor data, right? Or even get the analytics. So how do we optimize for the points which we should be focusing first? I mean, like in your case, you here focused on chillers. So likewise, there can be motors, there can be compressors, number of motors, number of compressors in the industry. So
Yeah.
how do we optimize number of points to be monitored?
Yeah. I'll answer your question. I'll answer your question by showing you some evidence. See, if I would be in your shoes, I'll be wearing your hat. Okay. So, what strongly recommended for any entity, you tell that person, okay, you tell me which are the big ticket items in your factory or your process. So, for example, even if I take a manufacturing process, let me take my example, or a light engineering industry. Light engineering industry, everybody understand. One of our after compressors, after air conditioning, that is, you can say, utility. We have got pre-treatment process where the metal sheet comes, raw metal sheets, and that is processed, and you get a final product. So, be it a refrigerator, be it a cupboard, be it a furniture, be it a air conditioner, or be it an automobile. See, you go to Mahindra, you go to Tata, they make automobiles and all that. So this process is mostly common. So raw metal sheet comes, and then you have to degrease it. There is a phosphating process, and then there is a water drying, and then there is a powder coating, and then there is a powder curing. So for which you have got a battery of pumps, around 13, 14 pumps are there. Then you have got blowers. Then you have got ovens where you do your heating, etc. So this is one big ticket item. What I'm saying is, so like that, you have to do a walkthrough audit. Okay, walkthrough, you go through, ask them, and say, okay, you tell me, you show it to me, and tell me estimated. These are your big ticket items. This is actually what I have been doing. Okay, after Godrej also. So then once you are aware of it, then you push them, motivate them to install energy meters. Now, again, let me tell you, energy meters are available for 18,000, 20,000. Energy meters are available for 7,000 also.
Yeah.
Now, you may ask, what is this? For the processes, sub-processes, or subsystems metering, our main intention is to have energy. Okay. So no sense in putting a high-end meter, which gives you harmonics and blah, 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 some 20, 30 parameters, which I must have also seldom read hardly in my lifetime. So we are interested in voltage, current, power factor, frequency, KVA, KWH, KVH. Nowadays, KVH ka billing hota hai everybody. Okay.
Yeah.
So this meter will be around 7,000. It could be a little bit less also, it depends. So tell them to put the meters in place, number one, first of all, with RS485. Okay. Second thing, as an integrator, you'll have to work out an action plan and tell them that if the meters are in the proximity, see, for example, again, I'm taking pre-treatment. Pre-treatment is one long panel. You'll see from east to west, and there'll be a lot of pumps and everything in one panel. And if there are meters, sub-meters for pumps and for blowers and etc., then you can do a loop in, loop out, okay. And then you can have one modem or one device, where you link it, and then you can upload the data to the cloud and take it. So you'll have to work out this strategy and then show them that, look, after your total 100% of your energy, we have been able to map, say, 60% of the energy and tell you that from that 60%, which is 100%, tomorrow this is 30% or 20%, and you should have some more. Then they have to do the reverse thing. They should also map what is the output. So output is measured in square meter of sheet, which is powder coated. Okay. So ultimately the process is powder coating. So you'll have to see how much is the powder process. So then you'll have to correlate in that same thing in your energy management system. Okay. If it is coming from an ERP, those things, the data are now fed in the ERP. You can link it, integrate it, and then you can have a specific energy consumption coming for a treatment or a powder coating process, and say, for today, the production was X, for which the energy was Y. Tomorrow it was X plus something, it was Y minus or whatever it is, and then create a baseline. Then you will know what is a fixed load. Because see, if you are putting 10 sheets or if you are putting 1,000 sheets, the oven has to be heated for 800 degrees or 300 degrees, whatever it is. The pump may run. Pump with VFD, it may come down, but it may not come down that. It is not a linear expression. So answering to your question, first, you'll have to do and understand the mapping of a high energy consuming areas, or we call it as a big ticket item. Put the meters in there, integrate it, give them the proof of the pudding and give them a taste that, see, this is where you are getting the benefit. This is where the analytics is happening. Okay. Or possibly now a lot of people are outsourcing. You yourself can have a team deployed at a cost. They say, okay, I don't have a team to do analytics, because you require knowledge also. You require skill also. So then that is also another field, another avenue for business opportunity, you can say. And you'll say, okay, my person will come and sit once in a week and we can do this analytics and we will give you the report. It's like your health checkup. How you go for a health checkup once in a year. We'll give you a health checkup every week, or you give that data access from outside. Okay, it's on a cloud. So I'll give you the report and then tell you where everything is going wrong. So we put our manpower. You need not put your manpower. So it could be totally wet list type of a solution. So I hope I have been able to answer your question.
Yeah, very much. Yeah, thank you so much. Now there's a question from Mr. Padu Padmanabhan, and like we are blessed to have him in almost every session. So here's the question from him. So there appears to be interest in Indian industry in conducting energy audits. Little interest in establishing energy measurement and verification systems. Could you comment on this difference in attitude, since one needs both to implement and track energy savings?
Padmanabhan sir, good evening. Pleasure to interact with you. Anyway, see, yes, I fully agree. I am very vocal about it, and I am very candid also about it. See, the whole issue which I have been seeing in the industry is that, yes, people would spend a lot of money in buying new equipment, but to monitor, I'm telling you, I'm giving you a very simple example. The compressor. The compressor is costing what? 15, 20 lakh rupees, nothing less than that. It depends, whatever is the capacity. And when we say you put a flow meter, the flow meter cost will be for a 2-inch line or something will be 1.5 lakh rupees. So बोलेगा क्या जरूरत है? What is it? And they don't even put the energy meter. So the compressor is running, but they don't have a clue how the compressor is working, what is the loading, unloading. They will be very happy that this is a VFD wala compressor. So first thing is a mindset, number one. Secondly, somebody has to show that, see, look, so when the energy audit happens, what energy audit is happening, again, with my due respect, I got a lot of our associates and friends. It's like a health checkup. You go in a hospital on one day, the doctor takes the parameter, but that doesn't say that you are healthy throughout your life, throughout the year. So ultimately, one has to make them realize that, look, energy audit is a one-time measurement. It is telling you at that point instant how is your performance. But tomorrow, for some reason, because of operational reasons or some technical reasons, things are deterring, you will not come to know. So you have to prove the point, bring home the point. The second issue, as I was telling to Bhavnaji, that, see, people are having challenge. Even I had a challenge. People come and people leave. You train them, okay. It has now this industry has become like a coaching class, So then you develop a skill, that person gets developed, he's managing your entire show of energy management. All of a sudden he leaves, then you have to requisition a new manpower. You don't get a trained manpower, okay. Colleges don't have this type of a curriculum, neither people are aware of it. To train them again, it's 1 year, minimum 1 year, you to get him into the group. Believe me, where he will operate independently, where he will understand, do everything on his own, So then people say, boss, it's not worth it. मैं क्या करूँ? आदमी जाता है, आदमी आता है. People are coming and going. I manage the show. A maintenance fellow will say, my priority is maintenance, not this. If the energy does not get saved, I am not going to get wrapped. If the maintenance, any breakdown, then I'm going to have a wrap on my performance management system at the end of the year. I'll be rated poor, etc., etc. So that's what I was telling Bhavnaji, that you look at it as a turnkey solution. You don't worry. I will manage it. I put my resources and I'll give you the result. So you'll have to really show some sort of a merit and show them that, yes, this is what is happening. So these are the challenges which we have experienced even managing the systems. As I told you, a lot of places I go, meters are not installed properly. And then there is a fight between the meter OEM and the client. And then the meter OEM says, see, boss, it's not my fault. In fact, I have been telling a lot of people, don't do this, don't do this, do this. They say, oh, we never know about it. So again, the knowledge, awareness, that also is very, very scarce, So all these things put together, packaged together is preventing this monitoring and verification, measurement and verification taking up on a greater scale in Indian industry.
Thank you very much. Now, another question is also from Mr. Padu Padmanabhan. His next question is, how can data analysis be used to conduct gap analysis? In other words, how do you see data analysis used as a tool to compare inter-company energy performance as well as inter-country performance for a specific industry subsector?
Well, this is a very good idea, concept. But again, my challenge I have been facing that people are averse to sharing their data. Okay, people are really averse. When we are saying inter-industry, even I cannot name certain organizations or say even location to location specific data, people are saying no. This is we are same company, a little bit different business or the same business, but we don't want to share and all that thing. And getting the proper data, data validation. There are a lot of times data are not coming properly. So those type of communication gap and willingness and openness to come out. See, because we had a lot of this business excellence assessment, the CII business excellence which is going on, and every time assessor used to tell us that who are your competitors, even the green co, and many times we say we are not having the competitors data from the market because it is not available in the public domain. And of course, if I go to a competitor and ask, please give me your data, you all understand, people will never share that data. So one thing is getting the data. The second part, the earlier part, which you said, the gap analysis. Yes, I have got systems. The design is X. The operation is this. So once I implement the system, right from the day one, and then all these data, once I give it to the auditor while doing the audit, it will really, really add value to the entire energy auditing process, which I have experienced. I'm not able to name, maybe those people are attending this session. Okay. So one or two audits which has happened. And after this implementation system, thank God, thanks to the management giving us this permission to do that, we were able to share this data during the audit. Okay. And we were very well poised, and we could leverage the energy auditing process and the outcome of it. And it was a great value add. It really very helpful.
Yeah. Mr. Padmanabhan, I hope that answers your questions.
Yes.
Yeah, thank you so much. Now,
answers it very well, I should say.
yeah. Yes, of course.
Whatever practical experience I got, I'm trying to now disseminate and share it with everybody.
The first question on energy audit, as you very rightly said, Mr. Engineer, energy audit is only a way station. It's not the destination. The destination is your energy savings.
Yeah.
Unfortunately, there's no meter in the world which can meter energy savings. You have a before and an after. You don't have a single meter. So for a before and an after, you need an M&V system. If you don't have an M&V system, you'll never know how your equipment is performed, as you very rightly said in all your case examples. And that basis is your M&V system and the data analytics that follows. Both together has to be seen as one comprehensive kind of a strategy.
Yeah, there has to be a consonance. There is a dissonance.
Exactly.
Actually, today there is a dissonance.
There is a dissonance. You're absolutely right. This was very useful. Thank you very much, Mr. Engineer.
Welcome, sir. Nice meeting you, sir.
Nice meeting.
Now there's another question from Mr. Nageshwara KH. His question is, by implementing IoT-based EMS, is it possible to avoid manual energy auditing process, and to what extent?
See, sir, it's like this. Energy auditing, as I told you, let's compare it with a health checkup. So today I went and I got a health checkup done. Now the issue is, I'm just referring to myself, that I have been detected as a border case with sugar. Okay. They call it as a type 2 something, medical line diabetes. Okay. So now what a doctor says, that there are two ways. There are two interventions. One is a medical one. The second thing is with a physical one. You go for a walk, you do exercise, you change your lifestyle, the food habits and whatever you eat. That is the prescription. So this is your energy audit prescription, whatever you are doing, air compressors or a pump. This is, I'm giving you a very good analogy. Now the issue lies with the client and with the patient to take walk every day for half an hour or 1 hour, number one. Not to eat sweet things, okay? Avoid certain foods which are junk food, which you call it, okay? Do yoga, blah, blah, blah. And you take a medicine also. And after 1 year, the medicine dose has also been reduced. It has been proven in medical science that by doing this intervention. So now by doing this ABC, the other things which you said, that is a data analytics, which keeps you informed. You have got that meter, glucometer. You check the sugar level yourself every month or every 15 days as prescribed by the doctor. And you are so happy that earlier my sugar levels was 200. Now it is within the limit of 120 post fasting and all that thing, blah, blah, blah. So this is where you have a check and balance. So data analytics is like a power steering to your car, which gives you a check and balance to maneuver your car. As Mr. Padmanabhan said, energy audit is a roadmap. It has given you the direction. It has given you the direction. Okay, you do this. But if you don't want to do that and only rely on the medicine, unlikely your sugar level will not come down from 200 to 120, which you desire to do that. So this is something I'm trying to give an analogy. Hope I have been able to explain.
Yes, sir. I hope that answers your question, Mr. Nageshwar. Any other questions? Sir, can we go to the screen where your contact details are available? Some people have asked for that.
Okay, so I will put it over here only, or
Yeah.
I'll just put it immediately over here.
Yeah, you can just. Yeah, and if anyone wants to ask question and want me to unmute your mic, please let me know. So if there are.
Or I can be reached at my Gmail also.
Yeah.
I will respond, or
Yes.
somebody can call
Yes.
me. Now
Yes,
I think
his
so.
email and yeah, phone numbers are on the screen. You may please note it down.
It's visible, na? Or I should
Yes,
enlarge
it
it.
is. No, it's very much visible.
All right. So hope
Yeah.
I could meet the expectations of the delegates, the participants participating in this program. Thank you very much
Absolutely.
once again for the opportunity. Thank you.
Absolutely, sir. Yeah, thank you so much for the wonderful session. And we really love the session. And before we end the session, let me remind you, to those who are interested for this membership. Now, membership for AEE is available for $40. You have to select Member International uh, 4 as the category, as membership type, so that you can avail membership of $40. And yeah, and if you have any questions regarding the membership, you can contact me. And those who have taken membership recently, you can just let us know that you have taken the membership. Yeah. Okay, so let's end the session here. It was a.
I'll stop sharing.
Yeah, you can stop sharing now. Yeah. So again, the next session is on 28th of April, and by tomorrow you will be having the topic, and time is as usual 3 p.m. on Fridays. So second and fourth Fridays are reserved for this AEEWI Western India chapter, and our endeavor is to bring in very experienced speakers each time, so that the energy fraternity and those who are interested in sustainability can learn more and more and make use of this forum for learning and in profession as well as academics. So thank you so much for attending, and we hope to see you each in each session throughout the year. Thank you.
Thank you
Bye.
very much. Bye. Bye. Thank you.
Yeah, there's some questions. So I mean, that is for membership. So membership period is up to December. Up to December, and life membership is also available. I will just Mr. Sharobindu, I will let you know about the life membership fees. I am not able to recall it right now, but I am surely respond you to by email. Thank you so much. Thank you. Goodbye.